Next, we're going to look at number 38 here. We're going to write an equation for the nth term, not the general formula, but a little more specific if we're given a couple of pieces of information. And we call that, again, finding the explicit formula like we did with arithmetic. Okay, so if you remember, the general formula is an equals a1 times r to the n minus 1 power. Okay, but we're given a1 and we're given r here, so we can get more specific to this particular sequence, and we're going to say an equals a1, which is 4, times, and show that with a dot. We're going to put our r inside parentheses and to the n minus 1 power. Now, a couple things here. We cannot simplify this any further. That is our explicit formula for this sequence, with our first term being 4 and r being negative 6. I can't multiply the 4 and the negative 6, because if I actually knew a value for n, I'd have to put it up in the exponent, subtract 1, and do that exponent first before I multiply. So we can't really simplify this one like we could a little bit with the arithmetic sequences. Now, if we go down, we're going to also do geometric means, just like we did with arithmetic means. And the definition is very, very similar. You're finding the missing terms between two known terms in a geometric sequence. And so we're going to do it in a similar manner. This is going to be a1, your first known term. This is going to be an, the last term that you know. But now, if you notice, I've got 4 blanks missing in between. So I'm going to call this also a6. Now, why do I do that? Just like with arithmetic, we then know that n is equal to 6. Okay, so I'm going to go to my general formula. And again, that's an equals a1 times r to the n minus 1 power. And if we can figure out r, then we're going to know what we need to multiply by to find those missing blanks in between. So if I do that for this problem, I'm going to substitute in an, which is, that's this right here, that's negative 1024, and that equals, I've got a1, which in this particular sequence is negative 1, times r, and I'm not going to put parentheses around it right there, and I know that n is 6, so if I have r to the 6 minus 1 power, this would be r to the 5th power. Now, when you're going to solve for r, you always need to undo the multiplication of what's multiplied out in front of it, which is going to be that a1. So in this case, we're going to divide both sides by negative 1. So I will get 1024 is equal to r to the 5th power. So how do I find r? Well, if it was r squared, you take the square root. So to find r, I need the 5th root of 1024. Now you need to know how to do 5th roots on your calculator, and if you take the 5th root of 1024, you get r is equal to 4. So that's what I multiply by. So if I want to find my missing terms, I'm going to take my negative 1 multiplied by 4. It's negative 4. I'm going to multiply that one by 4. That's negative 16. I'm going to multiply that one by 4, which would be negative 64. And I'm kind of running out of room here, but if I multiply that by 4, I get negative 256. So I'm going to go ahead and write these down below. So my answer is, for my geometric means for this problem, is these 4, but I'll just write it a little bit neater here. Negative 4, negative 16, negative 64, and negative 256. So geometric means are the missing terms in between two known terms in a geometric sequence.